Taiwan Island is located at a high earthquake activity region, where 2,000 earthquakes per year in average. Although earthquakes are not predictable at the moment, with the aid of accurate seismic wave propagation analysis, we could simulate the potential hazards at low distance from possible fault sources by understanding the seismic wave velocity structure of the Earth and the rupture process during large earthquakes. A framework made of 8 infrastructure supporting earthquake sensor network, data center, and also simulation of seismic wave propagation was implemented. The missions of data center are integrating seismological resources and to provide a platform for data access and sharing. Data content in data center, which including waveform data, parameter data, geological data, and so on. The data center is a portal for earthquake data management and data searching. We also created a 3D visualization system for viewing earthquake focal mechanism symbols 3-dimensionally. The system operates within the Google Earth software and web. The common parameters for a seismic simulation are region, model, earthquake source, and stations. The gateway provides a simulation wizard to help users setting up these parameters. So far, we provide a velocity model for global, Southeast Asia, and Taiwan, these 3 defined regions, and 2 ways for user to determine the earthquake source. One is to upload a self-defined source, and the other is to use a historic source from global CMT site. Default stations are provided. Furthermore, user could add extra station which he is interested. The simulator will generate seismogram for those stations located in the specified geographical scope, which is defined in the region parameter. After all parameters are determined, click Submit button to start the simulation. The gateway also provides a job monitoring panel. User can see the status of submitted job or program progress. When the job is done, the monitoring panel will switch to a seismogram viewer. In this viewer, the table at left side shows the station list with the seismograms available. User can choose a station from the list to see its synthetic seismogram. Based on the collaboration, an accurate regional model could be built by integrating more detailed topographical data from each participating countries. This is indeed the key to construct a useful and unique risk analysis for disaster mitigation.